We're going to do a Camtasia for topic 5, quiz 5, the integumentary system. And as always, I want to express a huge amount of gratitude to Professor Montgomery for all the assistance she gave in getting this material together. We have Pansy the Answer Dog here. She's had breakfast and she's ready to go, very attentive, although she looks like she might be going into a coma. So here we go. The skin can be called a couple of different things besides skin now that we're no longer in nursery school. Sometimes it's called a cutaneous membrane, or sometimes it's called the integument. It covers the body, and a normal person has about 20.83 square feet of surface area, although I suspect there are some people on the Patriots team that are larger than that. It's an organ, and it's an organ because it includes a number of different kinds of tissues. We have epithelial tissue, connective tissue, muscle tissue, and nerve tissue. You remember that organs are groups of tissues and cells that have at least one specialized function. It also sometimes is considered an organ system. It has accessory organs, and we can we'll address those in a little bit. There are two layers, and those are joined by the hypodermis, which is a basement membrane. The two layers are the epidermis and the dermis. So here we have a drawing of the layers of skin, and the hypodermis is mostly loose connective tissue, but you can see the epidermis and dermis and how they're associated. You can see that there are these extensions of the dermis up into the epidermis, and we'll be talking about those. The hypodermis is going to be between the skin and deeper structures. Usually it'll be between the skin and muscles, although sometimes there are no muscles. The hypodermis exists between the skin and bone or other connective tissue. And if there is bone there, the hypodermis attaches to that. Okay, the epidermis. Outer layer, and it's thin. Typically it's stratified squamous epithelial cells. You recall that squamous cells are sort of shaped like a pancake. They're flattened. And there are actually 5 layers within that. There's only one of these layers that I'm particularly interested in you focusing on. But we have a stratum corneum, the stratum lucidum, the stratum granulosum, stratum spinosum, and stratum basale. The basal layer is the one that you really need to learn a little bit about, because that's where the cells that make up the rest of the skin are generated from. The epidermis doesn't have its own blood supply. This is a fairly unusual arrangement. Normally cells have to be close to a functional capillary in order to survive. And in the case of the epidermis, the cells get their needs taken care of by the adjacent tissues and organs. And so you might wonder, how can this be? How can the epidermal cells live without their own immediate blood supply? The answer is basically they don't do a lot, and the outermost cells are dead anyway, so they don't have any requirements. There's no intercellular matrix. We've talked about this before. This is kind of a peculiar attribute of tissues. Most tissues have at least some intercellular matrix. And we start with the stratum corneum. So cells are generated in the basal stratum and gradually are pushed toward the surface. And as they do that, they become flattened. They also become hard. And they become hard because keratin, a protein, becomes incorporated into the cells. And this keratin does a couple of things. One is that it causes the cell to die, but it also makes it waterproof. And the waterproof is important. It means that our skin is basically a barrier between water entering and water leaving our tissues. Gradually, as these cells are pushed outward, the outermost cells fall off. The skin is going to be a mechanical barrier against bacteria, the epidermis specifically, and that's an important function. I mentioned the waterproof nature of the epidermis. This is because of the protein keratin. Most cells in our body don't have very much keratin, and there are some areas in the skin or the epidermis where the cells become dead and thickened. That was kind of exciting. We have the stratum lucidum. This is going to be deep to cranium, and this is where calluses form. Calluses have a protective role, a protective function, especially where there's going to be friction. A lot of people are sort of not happy about friction, but in the areas where we do have it, having the calluses is very useful. The places that you tend to find these are in the palms of your hands, the soles of your feet, and at the elbows. And actually the palms of your hands and soles of your feet have a special kind of cell, glabrous epithelial cells, which are especially resistant to physical abuse. That turns out to be really important in protecting the underlying tissues. We have stratum spumosum and stratum granulosum. The spinosum has the ability to have mitosis, cell division, and there are fibers of keratin within this layer that gives it sort of a spiny appearance, hence the name. The granulosum cells, those are flattened, and they have protein granules in the cytoplasm. The cells are actually attached to each other, and this, as I mentioned before, forms a barrier preventing material from coming in or leaving the body. Excuse me. The stratum bacilli, or German, wow, I'm going to have trouble with this one. Germinativum, I don't usually call it that, or the basal layer. This is going to be superficial to the dermis, and this layer really is quite important because there are stem cells within this layer that divide all the time, and they push the cells toward the surface. Remember that at the surface, the dead cells are gradually shed. It takes about 2 to 4 weeks for these cells to reach the surface. And as the cells move toward the surface, they become flattened. So the cells, as they move outward, move further and further from the blood supply. As a consequence of that, they die. And that's actually coupled with the keratin. The keratin also causes them to die. Keratinocytes make up about 95% of these cells, and they have a couple of functions. They produce and store keratin, and as they get more and more protein incorporated into them, they enlarge. The Langerhans cells. Langerhans cells are macrophage cells. And we can look at that macrophage. It means something, right? Macro means, Pansy knows this, right, large. And phage means, right, to eat, which is one of Pansy's favorite occupations. They're a type of white blood cell, and they phagocytize microbes. This is an important part of our immune system. When they do this, they move toward the lymphatic organs, and when they get to the lymphatic organs, they stimulate an immune response. Excuse me. Melanocytes. Melanocytes are important. They have melanin associated with them, which is pigmentation. And these cells are responsible for the color of your skin and the color of your hair. And melanin is a brown pigment, and there are different degrees to how much of this pigment is actually produced. But if you look at all people from all over the world, you find that the number of melanocytes in their bodies is pretty much the same. But how much pigmentation you get really is determined by how much melanin those particular cells produce, and that's a genetically determined attribute. If you're exposed to sunlight when you go outside, the exposure to the sunlight causes the melanocytes to produce melanin, and the melanin does a couple of things for us. It protects the skin from UV radiation. UV stands for ultraviolet, and some of you are probably aware that ultraviolet radiation is a high energy electromagnetic radiation that, Pansy's rolling her eyes at that, that can damage your DNA. And if you get enough damage, you end up with skin cancer. We're actually going to talk about skin cancer a little bit later in this lecture. The melanin is going to be passed to other cells from the melanocytes, and this is the process of tanning. And I'm sure all of you are familiar with that. Some people lack the ability to produce melanin, and these people are sometimes referred to as albino. It's albinism, and there is no pigment in the skin, eyes, or hair. So their hair would be white, and their eyes would be pink, and their skin would be very, very pale. Because they don't have any melanin, they're especially prone to damage from UV light. There's another pigment that's produced, a yellowish pigment called keratin, and these are going to be found in, or this pigment rather is going to be found in the epidermal cells and cells in the dermis. So fair-skinned people are pink in color, or very light in color, but the pinkness is actually due to hemoglobin in the red blood cells. Okay. There are sensory cells in the basal layer as well, and these are particularly sensitive to and give rise to sensations of pain, and they are sensitive to temperature changes. There are also tactile cells. These are sometimes referred to as Merkel cells, and these are sensitive to touch. The dermis. Dermis is going to be deeper and thicker than the epidermis. It's made up of irregular connective tissue, and there are dermal papillae. So if you remember back when we looked at that picture of the skin, I showed you there were these little irregular projections from the dermis up into the epidermis, and those are the papillae. They sort of look like little pimples, I guess, in a way. So they project into the dermis, and they do a couple of things for us. One of the things that they do is they anchor the epidermis so that it doesn't move a lot, and they cause ridges in the epidermis, and these ridges are actually helpful in forming a grip, holding onto things, and they're also responsible for fingerprints. So here is an exposed drawing to especially show the papillae. You can see them right here. You could see them in the other drawing as well, but this one has been peeled back so that it becomes a little more obvious. Okay. There are collagen fibers. We talked about collagen in the past as a protein fiber that's strong and flexible. The flexibility is important. They help preventing tears in the skin, and overstretching is resisted by these fibers. There are also elastic fibers, and as the name implies, these are able to stretch. This is especially important during pregnancy, usually in women, because the skin in the abdomen can become quite stretched and if there were no elasticity, there would be permanent damage done to the skin. It also helps maintain tension of the skin over the underlying tissues. And then blood vessels. Blood vessels do make their way into the dermis. They grow into the dermis. By the way, that's one of the things about blood vessels that's not always intuitive. Blood vessels are dynamic, so they can actually grow into areas that are in need of materials, resources, and waste removal. And the blood vessels do grow into the dermis. They bring nutrients in that they deliver to the dermis and to the epidermal cells. If you have these blood vessels dilate, it causes a condition we refer to as blushing. If they constrict, you get a condition known as pallor. And if you get low blood oxygen levels, they become cyanotic, which is a blue color. Also, if there's enough compression of the epidermis and dermis, the blood doesn't permeate these layers, and it results in bed sores. And bed sores typically occur when you have protracted low blood flow into an area, and the cells start to die, and the tissues break down. Rather unattractive eventuality. So if you have pets or people that you work with that are in one position all the time, you really need to move them around so that their tissues don't break down. The hypodermis. Hypodermis is mostly loose connective tissue, including adipose tissue. We've talked about adipose tissue and its functions before. Remember that it's used for energy storage, and I hope you'll remember too that it's especially efficient for energy storage because we get more energy and less weight, and it's flexible. Those are good things for movement. The adipose tissue is good for thermal insulation. So people that have adipose tissue are more resilient to temperature depression. I'm sure you're aware of the mammals that hibernate and things of that nature. They become fairly inactive in the wintertime, and their adipose tissue helps them from going into hypothermia. Marine mammals are another extreme example. Adipose tissue is also good for padding against physical harm. And so there are areas in the body where adipose tissue tends to accumulate. It's not random, and those areas sometimes are useful in terms of preventing physical harm. We have accessory structures of the skin. We have hair, we have fingernail and toenails, and we have glands. And we'll talk about each of these a little bit. I'm going to start with the hair and the nails. If you remember, I think we talked about this perhaps before. Hair is a mammalian characteristic. Hair comes from embryological origins that were basically scales. And you know, this is for mammals. Obviously, reptiles have scales. Reptiles gave rise to the mammalian lineage, and they also gave rise to birds. And birds don't have hair, but they have feathers, which are modified scales. There are some places where we don't have hair. You don't have hair typically on the palms of your hand, the soles, your lips, nipples, and some of the external genitalia. Also, the patterns of hair growth change at puberty, and this is because of the sex hormones. Okay, so hair comes from hair follicles, and these follicles form from epidermal cells. They're found in the dermis, and the hair matrix is going to be have the follicles at the base of the hairs. The hair follicles divide, the hair matrix divides, the cells divide, and they give rise to new keratinocytes. Remember that keratinocytes incorporate keratin, the protein, into themselves, and these keratinocytes form the hair. Then the cells move away from their source in the follicle and they die. So what you see on people's bodies, the hair, is mostly dead stuff. but the root of the hair is in the follicle, and then the shaft extends outwards and away from the skin. Okay, so eyelashes typically live from 3 to 4 months, and your scalp hair lives from 3 to 4 years. Now, some people have alopecia, which is a hair loss. There are a lot of things that can cause this. And one of the things that's used to reverse this hair loss is to give drugs that increase the blood supply to the follicles. If you decrease the blood supply to the follicles, which happens in old age, then the hairs start to die. So each hair is going to have a sebaceous gland associated with it, and the sebaceous gland ducts empty into the follicle. There are also smooth muscles. These are erector pili, and they attach to the follicle. And we've talked about that before. Remember, these smooth muscles are responsible for causing the hair to become erect on the surface of the body. We have this happen in 2 conditions. We'll see if Pansy remembers, because Pansy exercises these erector pili quite frequently. One would be right when you're cold, and that hasn't happened yet this year. And the other would be right when you're frightened. And Pansy, she's wicked smart. So here we have the hair being erect above the skin, and you can see that there's dead space air in here. I think we've talked about this before. And the dead space air is not a good conductor of thermal energy, so it acts as insulation. Also, the way I drew this, the hairs don't actually touch, but in reality they overlap like shingles, so they actually form a barrier here. Okay, so it happens when we're frightened, and it happens when we're cold. See, Pansy was smart. She knew the answer. Okay, nails. Nails, too, come from embryonic structures that were basically scales. And there is a nail root. This is where the nail originates from, at the base of the nail. As the cells grow, they get keratin associated with them, which hardens them. And so what you look at when you see a fingernail or a toenail is this nail body. Then we have a cuticle. The cuticle is skin, and that covers the nail root. They grow about 1 millimeter per week. And the pink color of your fingernails is due to the vascularization of the dermal tissues deep to the nail. The lunula is white. That's near the base of the nail, and that is a thickened layer that has cells that are rapidly dividing. Okay, glands. The skin has glands, and glands typically are groups of cells. Usually, most glands are epithelial, incorporate epithelial cells. And they're going to produce materials that get secreted, and these glands are typically secreting into ducts. So we have several types. We have sweat glands, or sudoriferous glands. Sweat glands are found in all regions of the skin, but not equally distributed. So there are sometimes up to 400 glands per square centimeter in the palms and the soles of your feet, and then there are more in your fingertips. The sweat glands are tubular, and the tubule is sort of coiled. The origin of these sweat glands is in the dermis, and they become active under a couple of conditions. One is when you're under stress, for example, when you're taking a quiz or an exam. And those glands are also secrete when you're hot, and the secretion goes directly to the skin. That secretion then is going to evaporate. That takes energy away from the skin, and that helps us with thermoregulation. Some animals don't have very many sweat glands, and those animals have more difficulty thermoregulating. So perspiration is mostly water, although it's going to have electrolytes in it, and it has a number of small molecules. One of the small molecules that is in the sweat is urea. And you might wonder, well, why are we secreting those? Actually, the secretion of the electrolytes just goes along with the water, because the water is coming from the blood, and the blood has electrolytes in it, and it also has urea. Getting the urea released is actually excretion. That's getting rid of a waste product. So here's the thing that you should understand, because I think sometimes people figure, well, okay, so this is really excretion. This is how we get rid of this urea. It's not how we do get rid of the urea with the perspiration, but it's not how we regulate urea, and that's really an important thing to appreciate. Regulation of urea content in the blood is accomplished by way of the kidney, and not by way of your sweat glands. There are going to be two kinds of sweat glands. There are apocrine glands that open into the hair follicles, and those are going to be mostly in a couple of areas, in the anal region, the groin, and the axilla. They become active at puberty and continue to be active. And then we have eccrine glands that go directly to the skin surface, and these are the ones that are active when you're hot, after you've been physically active. So here's a drawing of the two types of glands. Here we see an eccrine gland going directly to the skin surface, the sweat pore, and here we see an apocrine gland going into the hair follicle. You can see how those glands are highly coiled. Ceruminous glands are going to produce cerumen, which is earwax. These are modified sweat glands, and they're found lining the external ear canal. And then we have sebaceous glands. We might have mentioned them before. Sebaceous glands usually are associated with hair follicles. They produce sebum, which is oily material. And the oil has several functions, benefits, if you will. One is that it softens your hair and your skin. It lubricates. It waterproofs. We're all aware that oil and water don't mix very well, so it prevents the skin from cracking and drying out. And it's bactericidal. And that's always beneficial, because obviously the surface of your skin is an area where bacteria you could be exposed to bacteria, and if you can prevent them from entering your body, that would be a good thing. Some people get acne. I'm sure many of you have heard of acne. The most common form is acne vulgaris. And acne is an inflammation of the sebaceous glands. It often becomes acute or more of a problem during adolescence. And the reason that happens is because of hormonal changes that are occurring at puberty. Lactiferous glands. Lactiferous glands are a type of sweat gland, and Pansy knows what they produce because she likes to have it. What do they produce, Pans? Right, milk. Okay. These are typically associated with the mammary glands, and there are 15 to 25 of these in each of your mammary glands. If you were to palpate them, they have a rough texture, and they do produce milk. The hormone that causes them to do that is called prolactin, and we'll talk more about those later on in the course. Here's the interesting thing. You might think, well, lactiferous glands are something that is a female characteristic. Actually, men have the same glands, and with the appropriate hormones, men can also produce milk, but I suspect we'll talk more about that eventually. So what does the skin do for us? Well, one thing is it protects, and it regulates water loss, and at the same time prevents water gain. It gets rid of excess water in some cases, and some waste material. We talked about that with sweat. It produces vitamin D, and vitamin D is an important precursor to a hormone that helps us regulate both calcium and phosphates. The skin gives us sensory information about what's going on in our surroundings, which is important for our well-being. And the skin also helps us regulate body temperature, and we'll talk about how some of these things happen. So, the protection thing. Protection the skin affords us is from physical harm. It's a barrier for the deep structures. The melanocytes, you'll recall, produce melanin. Melanin helps protect us against UV radiation. So UV light is kind of a mixed bag, right? We need UV light to produce vitamin D, and that's a good thing. But too much UV light can result in skin cancer, and that's a bad thing. So we're walking a fine line with that one. The skin is able to produce vitamin D because of that UV light. It protects us from invasion from pathogens because it's a barrier. Okay, and we already talked about sebaceous secretions are bactericidal. We have the Langerhans cells. Those are phagocytic. I think we might have mentioned those. And then we have the dead cells on the outside, and they're just a barrier for things trying to get entry into our system. In terms of regulating water loss, you'll remember that we have the keratin in the cells that makes the skin waterproof. That prevents water from coming in, water from going out. Prevents water loss. It also prevents water gain. The skin is going to help us. Okay. Well, I'm not selling drugs. I know many of you think I'm selling drugs, but I'm not selling drugs. Okay. The skin is going to help us eliminate water and waste. So the sweat glands secrete water. And there are two kinds of sweat being produced. The sensibles, which is actually something that can be felt, and insensible. And the insensible sweating, not really aware of this, but we are getting rid of water. There are also some excretion. I mentioned that already. Some of the things that get excreted include ammonia, urea, electrolytes, collectively called salts, and some other waste products. So the amounts of ammonia that are excreted are usually fairly low. The liver converts ammonia into urea, and then the kidneys get rid of the urea with the urine. But that explains why when somebody perspires into clothing and then the clothing sits around for a while, the clothing gets to have a fairly unattractive aroma, and that's because the urea is converted by bacteria into ammonia when the time goes by with the urea in the clothing. Good reason to wash your clothes. We have secretion in some areas. Secretion is a useful discharge. Usually secretions are synthesized by our cells, and so an example of a secretion would be a hormone. But you could have enzymes or many different things can be secreted. Excretion, on the other hand, is a discharge that's a metabolic waste. And generally, it's essential that we get rid of these things that are excreted, because if you don't, and their concentrations build up, they can become hazardous. There are a lot of those. Urea is an example, or ammonia. Those are excretions, and if they build up in your blood, they can make you ill. Also, carbon dioxide is a waste product, and we need to excrete that. Typically, we do that through the lungs, though. The production of vitamin D is a useful activity. Actually, that should probably be read. And the cells that produce vitamin D are the keratinocytes, and they do this when they're exposed to UV radiation. Doesn't take an awful lot. Minimal exposure per day can get your minimal daily requirement of vitamin D produced by your keratinocytes. There's a precursor molecule in the cell that is converted with the exposure to UV light. And then the vitamin D leaves the skin, leaves the cells, goes into the blood and is transported to the liver and to the kidneys. And the liver and the kidneys convert the vitamin D into calcitriol. Calcitriol is a hormone that's very important for calcium absorption from your gastrointestinal tract. And then once you have the calcium and phosphorus in your body, the calcitriol is important for metabolizing that calcium and the phosphorus. Calcium and phosphorus are the primary materials that make up your bone matrix, the hydroxyapatite. We'll be talking about the bones in the next PowerPoint. So calcium has a lot of important functions within the body. One is that, and this is not a function, well, I suppose you could consider it a function, it's kind of an association. The intercellular matrix of the bone is largely calcium phosphate. It's actually hydroxyapatite, has hydroxide on it, but calcium and phosphate ions together. Calcium is absolutely essential for muscle contractions, for nerve activity, transporting or sending nerve impulses along nerves, for example. Blood clotting, you have to have adequate amounts of calcium or your blood clotting will be depressed. And then obviously production of milk in lactating mothers. If you have a deficiency of calcium, you get a condition called rickets. Rickets leads to deformed bones. They are soft and don't support the body weight very well. And then we mentioned the sensory information that you get from your surrounding by way of the skin. Receptors in the skin are sensitive to a couple of things. You get pain, sensitivity to heat, sensitivity to cold, pressure, and touch. The highest density of the receptors is in your fingertips, and probably most of you are aware of this. If you palpate things with your fingers, you can really feel the most subtle irregularities, whereas other parts of your body, for example, over your vertebral border is very low density, and you don't have very good perception of tactile responses as tactile stimuli. Regulating the body temperature is a big deal. If our body temperature gets too far out of range, either plus or minus from the normal state, you can become quite ill and die. Now, muscular activity gives rise to heat. More than half of the energy that muscles release when they contract comes off as heat. And when this occurs, when you become physically active and you start to heat up, the smooth muscles and the vessels in the skin relax. This causes vasodilation. It's called vasodilation. That causes more blood to get into the area of the skin, which then radiates the heat. In addition, the sweat glands in the skin release perspiration. That water is going to evaporate, and that removes heat from the body as well. So the evaporation of the water cools the body off. If the body's cool, instead of having vasodilation, we have vasoconstriction. Muscles of the vessel walls get smaller, less blood goes into the surface, so the heat is going to be conserved in the body cavity, in the tissues of the body itself. So you get less radiation if there's less blood going out to the skin. And then when you're cold, your sweat glands still release perspiration, so you're not having evaporation at the body surface. Okay, another thing that happens when you're cold or cool is that you shiver, and basically when you're shivering, your muscles are contracting, but there isn't any movement of your body. And as I mentioned before, well, I think I did anyway, a little more than 50% of the energy that's released by muscles when they contract goes off as heat. Also, when you're cold, the erector pili muscles contract, the hairs on the surface of the body become erect, and this helps insulate. For most mammals, not so much for humans. Most humans don't have enough hair to make really much difference. Okay. If you get exposed to extreme cold, then the blood going into the skin is going to be very restricted to help conserve the heat in the body core. And if you have this extreme cold exposure continue and persist, you may end up with frostbite, which kills the skin. The reason the skin dies is because it's not getting enough resources from the blood, and it's not being able to get rid of its waste products. So hyperthermia is a temperature, body temperature, that's above normal. There are a couple of degrees of this. 1 degree is heat exhaustion, and in heat exhaustion your temperature remains high, and there are a couple of results of this. Blood pressure drops and electrolytes are lost. Electrolytic imbalance can have rather dramatic effects on a person. Then if you have heat stroke, the temperature is very high, maybe up to 110 degrees. That's not degrees Celsius, that should be Fahrenheit. If you were 120 degrees Celsius, you would be dead. So mistake there. Note to students, note to self. And when you have heat stroke, there's no sweating. And then fever can be a manifestation of hypothermia. If you have fever, your immune system is an immune system response. And it seems to be counterproductive because fever typically makes people not feel well and not really behave in normal ways. The good news is, though, that this is usually in response to bacterial infections. It turns out that when you raise your temperature with fever, bacteria are deprived of some nutrients that they need at the higher temperature, and so bacterial infections sometimes subside when you have a fever. Okay. Typically when the fever breaks, sweating begins. Okay. Hypothermia is going to be a body temperature below normal, and depending on how much below normal, there are a number of responses. One is that you can have uncontrolled shivering. Your speech becomes incoherent. And if your body temperature drops to between 90 and 95 degrees Fahrenheit, you lose coordination. That when I have the right units, that's good. Okay. Pulse rate drops with hypothermia. That actually helps conserve body heat in the core. It can lead to hallucinations. This happens to people who get lost or whatever in the Arctic or Antarctic. They start to hallucinate if they get too cold. And then if you get down between 80 and 90 degrees Fahrenheit, you'll become unconscious. The breathing becomes really shallow. And your shivering decreases, and you start to become rigid. If it gets down into that range and it's protracted at all, you can have up to a 50% mortality rate. Obviously, it's helpful not to let it get to that stage. In terms of disorders of the skin, we have a few. We have athlete's foot. This is due to fungal infections. Impetigo, which is a bacterial infection, you get pustules. Candidiasis, which is a yeast infection, usually in moist areas. Eczema. Eczema is an inflammation of the skin. Some of you may be familiar with this. And it usually is a sensitivity to chemicals, to fabrics, heat, or dryness. In fact, this is one that can be induced when people are handling chemicals, especially people, for example, who are using cleaning chemicals to clean houses or whatever. If they're handling these a lot, sometimes they end up with eczema because of an increase in sensitivity to the material. And then dandruff. We've all heard of dandruff, I suspect. Here, we have accelerated keratinization of the cells. More keratin is being incorporated into the cells. We have hives, urticaria. This is an allergic response. And then tattoos have become, and piercings have become very popular, or commonplace, I guess would be a better way to describe it. There's actually danger to poking holes in your skin, danger of damaging the underlying tissues, but also introducing foreign pathogens into your body. Skin cancer. So skin cancer, I mentioned earlier. Typically what happens in skin cancer is your DNA is damaged, and there are 4 major types of cancer. We'll look at some pictures of people suffering from these. Basal cell carcinoma, squamous cell carcinoma, melanoma, and Kaposi's sarcoma. And we'll start with basal cell carcinoma. Basal cell carcinoma is a skin cancer caused by ultraviolet light, UV light. It's the most common of the skin cancers. It is not likely to metastasize. So generally, if you're diagnosed with basal cell carcinoma, treatment will be suggested, but it's not usually like a crisis or anything of that sort. Typically, the basal cell carcinoma will depress your immune response, and if you follow through and get your treatment, normally this will be successful. It is possible that it can recur. So here are some pictures of basal cell carcinomas. Then we have the squamous cell carcinoma. This also is caused by UV light. Begins with the superficial cells, but it has the ability or propensity to metastasize into nearby organs, which is never a good thing. These can sort of be like warts, these carcinomas. They often bleed, and when they do, they don't heal. That's usually a bad sign. So here we see some squamous cell carcinomas. You can see the kind of nasty looking degradation of the tissues. This one really looks a lot like a wart. The melanomas, these are very likely to be malignant. They're dangerous. They sometimes look like a mole, and more common in fair-skinned people, especially people who get sunburns, severe sunburns. You want to understand that when you get sunburns, the damage you're doing is permanent and cumulative. So if you get a sunburn this year and then you get another really severe sunburn next year, you've damaged your skin cells, and although the cells try to actually correct some of the damage to the DNA, there are limits to what they can do, and so some amount of the damage accumulates. These are going to be, the melanomas are more common with people who already have moles, and in the last 10 years the rate has doubled. Perhaps because of degradation of the ozone layer, that certainly hasn't helped. There are 9,000 people a year that die in the United States alone due to melanomas. So we have a ABCDE rule for examination of a mole. A, if the mole is asymmetrical, like oval or irregular. B is the borders. The borders, if they're not smooth, if they have indentations or notches. C is the color. If you have a mole that is sort of uneven in color, maybe even a number of colors. D is the diameter. Moles that are greater than 6 millimeters tend to be more dangerous. And E, evolving. That is, if you have a mole that's changing in color, size, or shape, that is more dangerous than one that's static. Here are some melanomas. Melanomas are potentially deadly and need to be addressed. And especially if you're fair skinned, it's at some point as you age, you really should start to get a check by a professional to see if you are suffering from some of these things. So in order to prevent these skin cancers, there are a couple of things you can do. Broad spectrum sunscreen is a really good idea, both blocking ultraviolet A and ultraviolet B radiation. Wear protective clothing, so long sleeves, gloves, hat with a wide brim, sunglasses, especially sunglasses that reflect both kinds of UV. And then the times of the day that you're most likely to have damage from UV light is between 10 a.m. and 3 p.m. And if you can go out earlier and later than this, you can reduce your exposure significantly. Another thing you can do to avoid getting skin cancer is to not use tanning machines unless you have a physician that's saying you've got seasonal affective disorder and you really need to be in a tanning machine. Tanning machines are not good for you. Kaposi's or Kaposi's sarcoma. This is often associated with people who have AIDS or people who have impaired immune systems for other reasons. And they actually can have some unusual colors, red, blue, or black spots. And typically these sarcomas respond to treatment for AIDS with an AIDS cocktail. So here are some Kaposi's sarcomas. Wound healing is an important thing. I think we talked about this in class. Typically, if you have healthy circulatory system, wounds will heal, especially minor wounds, will heal relatively quickly in the epithelial tissues. When you injure your skin, you get a couple of different responses. One is inflammation, where you have redness, swelling, and heat and pain in the area. If you have an injury that involves the breach of a blood vessel, the blood should clot. The blood clot is important because it's going to plug the wound and reduce the amount of hemorrhaging that you have, but it also reduces the spread of the toxins and pathogenic organisms through the rest of your system. So typically when you have a clot, part of it's exposed to the outside, to the air, and that gets dry and hard, and it becomes what's called a scab. And there are some enzymes in the clot that start to digest the clot, and it gradually starts to break down, get kind of crumbly, and fall apart about the time that new cells are pushing into the area. The kinds of cells that are attracted to the area include white blood cells, which can help fight against pathogenic organisms, and fibroblasts. Fibroblasts are going to have a couple of functions in helping in the healing process. So the white blood cells fight infections. The fibroblasts close the wound and promote the regeneration of cells. Okay. So the fibroblasts are also going to cause scar formation, and that pretty much ends the healing process. Scars typically are not as healthy as the original skin, or not as robust as the original skin, because they've lose some of their associated structures that would be there if there weren't a scar. So the scar is going to be made mostly of collagen fibers. Remember, that's that strong protein. and the accessory organs will be missing. So like skin, the hair, things of that nature. Yeah, when you get older, there are some not great things that happen. One of the things that happens is the mitosis of cells in the epidermis decreases frequency. So the epidermis is the same thickness as normal, but remember the epidermis was the thinner layer to begin with. The dermis gets thinner. The skin becomes looser because the deep fascia is not as stable with respect to the skin in terms of their association. And adipose tissue starts to decrease, so that does a couple of things. It reduces the ability to feel cold, and actually your hands and feet start to feel cold more often. You tend to bruise more easily. You're in greater risk of having bed sores because of the circulation becomes less effective. The dermis has collagenous fibers. They become coarser, thicker, and further apart, and less of them. The elastic fibers are lost, so the skin is not as well associated and resistant to stretch. And the elastic fibers rather, can be thicker and disorganized and less elastic. So people as they get older get wrinkly skin. This is because the epidermis is loose compared with the dermis. The dermal fibers are not as strong, and there are less of them. And then what is there is poorly organized. Okay. Hypodermis is going to have less padding than it had before. And so we're going to have less vasculature in the skin. This means that your responses of the skin, homeostatic responses, are going to be less effective. There are going to be fewer sweat glands. Hair follicles decrease in numbers. This is because of poor circulation. And there are fewer sebaceous glands, so that means the skin is prone to cracking and less resistant to bacterial infections. The melanocyte density decreases, and so your cells are not producing melanin. This causes your hair to lose color. Your hair turns gray. Your skin gets paler. And some of the melanocytes get larger. This results in a blotchiness of the skin, darker spots. And some of these changes are exacerbated by exposure to the sun. So for homeostasis, how does the skin interact with other organs or organ systems? Pretty much the skin interacts with them all, so we can kind of run through these. This will not be stressed on your quiz, but it does put things in perspective. You know, the integration of all the body systems is a big deal. Things don't just go off and act independently of one another, which is important. So the skin is going to protect the lymphatic system from physical damage and from infections. Remember, it's a barrier, and from UV radiation. The skin is dependent on the cardiovascular system for blood supply, respiratory, obviously, digestive for the respiratory gases and nutrients, and the renal system to help get rid of waste. So those systems all recondition the blood, and then the blood is providing an environment that allows the cells in the skin to be successful. The kidneys are going to help by regulating water balance and the excretion of waste, nitrogenous waste. Also, the fact that our skin is waterproof basically controls the water loss or gain at the surface. The sweat glands are going to secrete water. Remember, that secretion is beneficial because it helps us thermoregulate. The sweating also excretes urea, although as I mentioned before, that's not how we regulate urea concentrations. That's regulated by the kidneys. The kidneys can help retain what water you have less if you have excessive sweating, but eventually you have to consume water if you're sweating a lot, because you can't generate enough water internally through metabolic activity to replace what you're losing. If your water content, or if the amount of water decreases too much, then you end up with low blood pressure and all of the problems that comes with that. The skin is going to help the skeletal system with respect to calcium, and also the metabolism of phosphorus by forming vitamin D. Remember, the vitamin D is produced by the keratinocytes, which gets converted to calcitriol by the liver and the kidneys, and that hormone is going to allow the GI tract to absorb calcium from what you consume. I think I mentioned this in class, but I'll mention it again in case you missed class. The source of calcium is dependent upon how much calcium you can absorb is dependent upon the solubility of the calcium in the forms that you consume. So certain kinds of calcium are not particularly soluble, calcium carbonate for example, but calcium citrate is a soluble calcium material that you could consume and then absorb the calcium from your GI tract. The skeletal system helps the skin out by supporting it. In a number of places the skin attaches to bones. We talked about that. The nervous system. The nervous system is aided by the skin because of sensory information from the sensory receptors. We talked about the sensitivity to temperature changes, both hot and cold, pain, touch, pressure, things of that nature. And then the nervous system is helpful to the skin by regulating the diameter of the blood vessels, by controlling the glands and their activity, and also the nervous system is involved with thermoregulation by controlling the erector pili muscles that cause the hair to erect when you're cold. The skin is going to aid the muscular system by helping us get rid of excess heat when your muscular system is active. Remember, the muscular system releases heat when ATP is broken down in the cells. More than half of the energy released from the ATP comes off as heat. So if you're hot, the skin allows for vasodilation of the blood vessels and radiation of the heat at the skin surface. And also, if you're hot, the sweat glands will release sweat, which evaporates, and that cools the body down. In cooler temperatures, when you're cold, you shiver. Muscle contractions cause a release of heat, so that helps you warm up. But the skin helps in retain that heat by having vasoconstriction, so there's less radiation of the heat from the surface. Skin is also going to have the erector pili muscles contract and cause the hair to become erect, and that helps us with insulation. Although honestly, most people it doesn't make any difference, or not any significant difference. I'm sure you've all been to the beach and seen someone that you thought was a shrubbery initially, and then realized it was a person. But those people are rare, and they're usually men. Skin can be an attachment for muscles, especially facial muscles. So your facial expression is affected by muscle contractions. The skin has effects on it because of hormones. Male hormones, androgens, promote hair growth and sebaceous gland activity. Female hormones promote adipose tissue development in the hypodermis. So women generally have smoother skin. And sensory feedback from the skin is a is going to be affecting sexual arousal and response. Also, skin protects the fetus and the placenta as it develops. Lactiferous glands, and again we'll probably talk about this more later in the course, but lactiferous glands and the mammary glands are stimulated by prolactin to produce food, milk for the newborn. That's kind of a big deal. And that pretty much gets us through quiz 5. Pansy has gone into a coma, but I hope you all made it through, and we will get some more Camtasias produced so that you can refer to those if you need them. I hope this has all been good for you.